Hello guys, welcome to JG Chemistry. This is our second video on the solutions of memory based questions of CSIR-NET June 2021 exam, which held on 16 Feb 2022. So some questions we are discussing from the physical part, physical chemistry. So this is the first question where the equation is given to you and they are asking you to calculate the activation energy, EA. So if you are familiar with the Arrhenius equation, that is log K is equal to log A minus EA divided by 2.303 RT, then you can see the two equations are quite similar and you can compare the two equations and write down the figure here because they are asking you to calculate EA. So if you compare the two figures, you can cancel out the T here and finally you can bring out EA. The thing which you have to keep in your mind, the answer you have to bring in the kilojoule per mole because the options which were given was in kilojoule, and you will get here answer in joule per mole. 8.314 is the value for R and this comes in joule. So basically you have to multiply it by 10 to the power minus 3 to bring into kilojoule per mole. So this was the answer which was given 191.47 kilojoule per mole for the given question. Next question where they have given you a cell and its potential is given, along with that dE by dt is given to you and they are asking you to calculate del H in kilojoule per mole. So basically you should know the formula of this del G is equal to del H minus T del S, which is very simple equation. And if you are familiar with the term of free energy, which is minus NFE, and entropy equation, which is del S is equal to NF dE divided by dt at constant pressure, where F is a Faraday, N is the number of electrons, then you can rearrange the equation and calculate del H. So finally you can bring up with this formula for del H. So here we have dE dt given, E cell is also mentioned here, and N is for this particular cell is number of electron, which is 2. Faraday is a constant which is in 96,500. Temperature is 27 degrees centigrade, so it is 300 Kelvin. And you can put all the figures here. The answer which you will get is in joule per mole. Again, you have to remember that they are asking in kilojoule per mole. So you have to multiply it by 10 to the power minus 3 and you will get your answer which is closest to 168 kilojoule per mole. So basically while solving the physical problems, you have to just focus on the unit which they are asking and the conversions. That is important because to misguide you, they will give you the other option also where you will get confused easily. The next question was where they have mentioned the rate of decomposition of a gas was given when 10% reacted, and the other rate is also mentioned. They are asking you to calculate the N. So if you are familiar with the chemical kinetics, the relationship between rate and rate constant, that is R is equal to K square bracket of C raised to the power N. So this is the relation with the rate with concentration. You can either bring out, because their two rates are given at two different concentrations, so you can make this formula R1 divided by R2 is equal to C1 divided by C2 raised to the power N. Where the data is given to you, all four, you can calculate directly by putting the figures here and calculate the N. Or else you can take the logarithm of both sides and finally you can bring out this formula where N is equal to, after solving, log R1 minus log R2 divided by log C1 minus log C2. R1 rate is given which is 10 here and R2 is given 5. At concentration C1, which is they have given that 10% reacted means 90% is left, so 90% is 0.9 and 40% reacted means 0.6, right? 60% is left, so you can write 0.6 here. After solving this, you can find the figure and that is 1.71, and this was mentioned in one of the option. So if you are familiar with the formula, it is very easy to solve the chemical kinetics problem. Next problem was which molecule is microwave inactive and IR active. The molecules were given: nitrogen, acetylene, HCl and H2O. So first of all, what are the molecules which has microwave activity? That the condition is it should possess the permanent dipole moment. For IR activity, there should be change in the dipole moment during the vibration. So let's see, nitrogen, it doesn't have any permanent dipole moment, neither it is having the change in the dipole moment, right? It doesn't have any dipole moment, so it is microwave as well as IR inactive. So this is ruled out, nitrogen. Then you have HCl and H2O, both are having a permanent dipole moment, right? Because partial separation of charge is there in both the cases. So basically both the examples are microwave active, but they are asking you here microwave inactive. So therefore these two are also ruled out, though these two are IR active, but it is microwave active as well. So this is also ruled out. So final we have left with acetylene. Acetylene, there is no permanent dipole moment, so it is microwave inactive. And if you see, for the vibration, there may be stretching, symmetrical stretching or asymmetrical stretching. Symmetrical stretching will be IR inactive, but you will get a peak for asymmetrical stretching, so therefore IR active. So asymmetrical stretching for the acetylene will be IR active, therefore we can say the correct option for the given problem was acetylene. This question was from your group theory. So MSc students, you might have studied in your second semester group theory. So you should be familiar of how to solve such kind of problem. The improper axis of rotation is given as 3,6, and we know the improper axis of rotation is equal to proper axis of rotation into plane of symmetry. So we can represent it by C36 sigma 6. And we know that if sigma is even, then we can represent it E, identity, and if sigma is odd, then we can make write sigma itself. So if you write this here, because it is even, we can represent it by this E, and C36 we can split into 2, that is C33 into C33, which is equal to C36 only. And if you see, this C33 is nothing but identity. So we can write identity if you multiply all the three. So finally the output is identity. So basically the S36 is equal to E, identity. This option was given. Along with that, they are asking S63. So we can write same way like we have done earlier, C63 sigma 3. Now C63 we can also write C2, and being sigma 3 is odd, we can write C2 sigma, and we know C2 sigma is nothing but it is equal to center of inversion, center of symmetry, inversion I. So basically S63 is equal to I. This E and I was given in one of the option, and that was the correct answer. Next question, where they have given you the E value in electron volt, and they are asking you to calculate V square. Very simple formula is, we know that E is equal to half mv square, m was mentioned, so you can finally figure out 2E divided by m. So here only thing is the this energy is given in electron volt, and the answer they are asking in meter per second. Okay, so here meter square per second square. So now you have to convert this electron volt energy into joule first. So we know 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. So 13.6, 2 into 13.6, and the conversion value divided by m, which is given in kg. And we know 1 joule is equal to 1 kg meter square per second square. So if you write here kg meter square per second square, kg will cancel each other. You have left with meter square per second square. So your final answer was 4.78 into 10 to the power 12 meter square per second square. They are asking you V square only. So this was the answer. So finally, they have given one more question here. Cis form, where K1 and K2 rate is given for the transform. K equilibrium is given. K1 was mentioned here. They are asking you to calculate the time when the concentration of the product becomes half of the equilibrium concentration. So if you understand this question and you know the formula for the reversible reaction, right? This is a reversible reaction. The formula is ln is Xe divided by Xe minus X, where Xe is the concentration at equilibrium and this X is the concentration of the product, is equal to K1 plus K2 T. T is the time here and they are asking you to calculate T only. So here K1 is given, K2 you can calculate by using the formula K equilibrium is equal to K1 divided by K2. K2 you can calculate because both the values are given here. And the statement says that when the concentration of the product becomes half of the equilibrium concentration. So you can say they are asking X is equal to Xe divided by 2, half of the equilibrium concentration. K1 and K2 you have now, K2 you have calculated in per second, T is there. So you can solve this equation. After solving this, you can calculate T, which comes 290 seconds, and this was the answer for the given problem time they were asking. So guys, all the problems which we discuss, majority of the question you can make a note that it came from the chemical kinetics, and it is one of the important topic for CSIR-NET examination as well as for GATE examination. And if you are organic chemistry student, you can study Puri Sharma and Pathania book. You can get entire content in that book and solve many problems. You will have a good command on chemical kinetics and can score good in your competitive exams. So all the best, happy learning.